All right, I have just a couple more things that I need to show you to get you through those first 12 problems, especially starting from 5 and going through 12. Example 2, we didn't talk about what to do, but you do have to pay attention to the negatives. So once again, example 2 says, and this is on page 36, says the terminal side of an angle beta in standard position goes through the point -3, -4. Find the values of the 6 trigonometric functions of beta. All right, so it's the same as the last example that we did, except we've got negative numbers to deal with. Well, let's go ahead and sketch it. I like to sketch because things are easier to see. And let's think about it. I don't have to be exact, but to get to the point -3, -4, well, I got my initial side here. Terminal side is going to go through this point. It's at -3, -4. So some point down here. And then if I draw my rotation, you see the angle beta that we're talking about. But always, remember, whenever we try to look at that right triangle, we draw back to the x-axis. We think about how we got to that point. Well, this side was -3. This side was -4 to get me down here to -3, -4. Now I got to find r. So if I go up and I do my calculations, remember r equals the square root, parentheses are important here, of -3 squared, which is x squared, plus -4 squared, which is y squared. Now, if I run this through the Pythagorean theorem, r is going to equal the square root of 25, so r is equal to 5. So this distance here is 5. Now I could think about my definitions of the trig functions, because now I have the value of x, that is -3. I have the value of y, that is -4, and I have the value of r, that is +5. And then I can plug those in and into those definitions in terms of x, y, and r, and I've got what they want me to do, the values of the 6 trig functions of beta. I can also just look at my triangle and do what I remember from last year, which is sine is opposite over hypotenuse, cosine adjacent over hypotenuse. However you decide to do it, I don't know. But this is going to be an important thing to do, to be able to figure the values of x, y, and r on every one of these problems. And know what to do with the negatives. Sometimes they do come out. So if I got the sine of beta, that's going to be -4 over +5, which is a -4 over 5. Cosine of beta is -3 over +5. So I just -3 over 5. Remember the negative. You can either put it with the number that's negative, with the bottom number, or just out in front in the middle. I usually just put it out in front in the middle for my final answer. And then tangent of beta. That's going to be opposite -4 over adjacent -3. So -4 over -3. That's not my final answer, because two negatives make a, that's right, it makes a positive. So the final answer here for tangent of beta is +4 over 3. And then we'll go back and get a reciprocal function. So the cosecant of beta is, flip it over. Remember, sign won't change when you flip it over. It's just 5 over 4. And the secant of beta is -5 over 3. And the cotangent of beta is +3 over 4. And there are our 6 trig values. Okay? Now, they don't show a single example of what I'm getting ready to show you in the book. So this is just one that I made up, because they do have these in the problems. It always aggravates me about math books like that. But anyway, suppose that the point that you're going through is something like 610. And the instructions are the same. Find the values of the 6 trig functions. Well, we're going to plot that, okay? And again, it's just a sketch, so over initial sides out here, over 6, up 10, going to be something like so. Terminal sides over there. Let's say that they call this angle theta, all right? So here, it's theta. Draw back to, from the point straight back to the x-axis to get our right triangle. Put 6 and 10 in place. 6 is x, 10 is y. Do the Pythagorean theorem, or r is equal to the square root of x squared, 6 squared, plus y squared, which is 10 squared. So r would equal to the square root of 136. Well, guess what? That comes out to be a nasty decimal number. And their instructions are going to say, leave your answer in simplest radical form. That involves a couple of things. It involves breaking 136 down. Remember how you used to do it. I don't care how you do it, how you figured it out. But, if we did a factor tree, then 136 would factor down to 2 times 2 times 2 times 17. For every 2 numbers like underneath, we'd pull 1 out. And so we get a 2 on the outside and a 34 on the inside. And that's what we have. So there's r, and then x is 6, and y is 10, either place you look. And these are what we're going to use to get the values of the 6 trig functions. But look what happens. All right, so sine of our angle theta, that is equal to 10 over 2 radical 34. What's the problem? You cannot leave a square root, a radical, in the bottom of a fraction. They'll put you in math jail. I've told you guys that for years. So we're going to have to rationalize, and we're going to have to reduce. So we're going to do this way. Square root of 34, square root of 34. So on top, I get 10 square root of 34. On bottom, I get 2 times 34, or 68. And then I reduce 10 and 68, outside number with this bottom number. And let's see, they'll divide by 2, leaving me with 5 over 34. So my final answer for the sine is 5 radical 34 over plain old 34. There's the final answer for the sine. We got to do that for each one. Let's go back over here and do the cosine. Cosine of our angle theta is going to be adjacent over the hypotenuse, or 6 over 2 radical 34. Now, guys, I can reduce the 6 and the 2 before, I got out here to the end and I did the multiplication before I reduced, but I could do it early. I can say, okay, 2 and 6, that gives me 3 over square root of 34. And then multiply top and bottom by square root of 34, which is going to give me 3 radical 34 in the top over plain old 34 in the bottom. Okay? And then tangent, well, fortunately, tangent works out pretty easy. Tangent is y over x, so it's going to be 10 over 6. And that reduces to 5 over 3. Okay, so reducing, simplest radical form, all of that comes into play. I'm not going to go ahead and go into the other 3 functions. They're just reciprocal functions, but I will tell you, if you'll come back to your original and start with that, flip it over to get your reciprocal, it saves you from having to rationalize again. If you flip this final answer over, guess what? You got a square root in the bottom again, but you guys should be smart enough to figure that out. Anyway, this should get you through those first 12 problems.